In this video, I will describe why in-cluster rolling upgrade is a critical requirement for applications. A rolling upgrade ensures that there is no interruption to the application during the upgrade process, and it does this by operating multiple versions of the pods at the same time. In this example, we have two pods of version 1 of my application running at steady state. When a rolling upgrade is started, one pod of V2 is brought up alongside the V1 pods. If health checks are successful, one of the V1 pods is drained and terminated. In the same time, a second V2 pod is scheduled on the cluster. Once two V2 pods are running, the final V1 pod is drained and terminated. Let us watch a demo of this in action now. My application is called Rolling Upgrade. It has a single container called rolling that is based on a V1 demo image provided by Rafe. We have selected the rolling upgrade option in the upgrade policy. Now let us publish our application to a cluster. Now we will use Rafe's built-in debug diagnostics capabilities to view the status of the pods in the application. The information presented looks identical to output if the user were using the kubectl utility to interact with the Kubernetes cluster. Now let us initiate an upgrade of our application to use the V2 container image. Let us now navigate to the debug screen to monitor the rolling upgrade process. In a few seconds, you will notice that a V2 pod is running alongside the two V1 pods. Then one of the V1 pods is terminated, and finally, only two new V2 pods remain. The rolling upgrade is now complete.